if this is given joint A, this is RAV, this is RAH. Here this is B joint, only one reaction RB. So it is easily seen over here. Total unknowns are, this is number 1 unknown, number 2 unknown, number 3 unknown. This 3 unknown we can find out with the help of the 3 equilibrium equations like sigma H, sigma V and sigma M equal to 0. This is statically determinate beam. Second example, second beam, cantilever beam. Let us be understood over here. The beam, please, the beam whose one end is fixed, another end is free. Please be careful, the students are doing the mistake over here. This end is free compulsorily, this end is fixed because of this fixity it offers the 3 reaction. If this is A joint, then it is offers RAH, RAV and third is my moment M. So the 3 unknowns are over here. There is no reaction over here. I will repeat my words once again. The students did mistakes over here by providing some support. There is no support over here. So here 3 unknowns RAH, RAV and M. And we can determine these 3 things with the help of the 3 equilibrium conditions, that is sigma H, sigma V and sigma M equal to 0. So this second beam known as cantilever beam. Third beam, overhanging beam. Overhanging, the beam which is overhanged beyond the support. The beam which is overhanged beyond the support. Please see over here. The beam whose one end is hinge, another is roller and some part is overhang beyond the support. This is known as one-way overhanging beam. This is known as two-way overhanging beam. Here the unknowns are 3 only. We can determine with the help of 3 equilibrium equations. So this is also statically determinate beam. So in your syllabus we have to study these 3 types of the beams. Next, see the examples how we can draw the beam. Simply supported beam, 2 reactions generated over here because of the supports. Fixed, this is the cantilever beam, this is the fixed end. Be careful, this is free end and this is the overhanging beam. Practical examples, see overhanging, span is over here, support is over here. Next example of simply supported, this is the bridge is there. Here this span, this support is there. Here there is a supporting is over here, roller support. Here there is a hinge support over here. So this span is act as a simply supported span. Whenever you will visualize, you have a chance to visualize the over bridge, maybe near river or maybe in your city. Please be careful, see the type of the support which is acting and see which kind of beam will be there. Next example, overhanging beam. See the part, this beam is overhanged beyond the support. This is column is there, this part is overhanged over here and rest one beam is inside. A large portion, cantilever portion shown over here. Large balconies, cantilever projected outside. Simply supported, once again examples, the train is passing on the bridge, the span is of simply supported nature. Each span is of simply supported nature. Next example, yes, here just visualize this beam is there which is supported by the 2 columns over here. So this is another kind of beam known as the statically indeterminate. This is just shown for your example, which is not the part of the syllabus. It is known as the fixed beam. Here, overhanging beam, which is visualized clearly. The various combinations of the structural component, which is also visualized over here. Now, question may arise in the mind. Let's see the figure. A beam, place over here, with the two roller support. Can we say this beam as a simply supported beam? What is the definition of simply supported beam? Simply supported beam is defined as a beam whose one end is hinge, another is roller. So, this is hinge, this is roller. But if I will provide on the both the side roller, can we say this is a simply supported beam? Yes or no? Think twice in your mind. Now see over here with this animation. Two roller support is there. Beam is provided over here. Now, any force point load is acting inclined point load. There are two components of this point load, horizontal and vertical. These horizontal component lead horizontal displacement on the beam. Please see clearly this animation, and this lead unstable beam. So a beam which is supported on the two roller support is unstable beam, is not called as statically determinate or simply supported beam. Now beam reaction, as I stated earlier, simply supported beam, one is roller, one is hinge, offers the two reactions, over here hinge and one over here, and our intention is to find out the same one. Yes, this is the another types of the beam which is beyond the scope right now, but let us discuss within one slide statically indeterminate beam. Statically indeterminate beams, the beams which cannot be, the reaction component which cannot be determined with the help of the three equilibrium conditions. Sigma h is 0, sigma v is 0, sigma m is 0. These three are not sufficient to find out the reaction. We require certain extra. Please see this figure. This is the beam, one end is fixed, here the roller is applied, one additional reaction. This is a continuous beam, this is the propped cantilever beam. Can you guess how to find this extra reaction? This kind of beam civil engineering students has to study in the third semester. So this is the beyond the scope for the first year students. We require certain extra conditions, we require certain extra equations. Next, sign convention. Before we are solving the problem, we should know the sign convention. For horizontal forces, right hand side force is treated as a positive, left hand as treated as a negative. Similarly, for the vertical forces, upward is positive, downward is negative, and for moment, clockwise moment is treated as a positive and anti-clockwise treated as a negative. This is my sign conventions I am using for my study for the student's point of view. You can use the opposite sign also, vice versa is also acceptable. Next, let us take one first problem. Simply supported beam, application of point load W at the center L by 2, L by 2, and our intention is to find out the support reactions, means HA, RA and RB. Let us use the first equilibrium condition, sigma H is equal to 0. Fine. Now, what is sigma H? Summation of all the horizontal component of the forces acting on my beam. Visualize here, H is only acting, this 1, 2 and 3 are the vertical forces. So only HA is equal to 0. So we found out the first reaction, HA is equal to 0 over here. It means that a beam is subjected to vertical forces, then always this HA comes to be 0. Second condition, sigma V is equal to 0. Summation of all the vertical component of the forces acting at a point is equal to 0. assuming, as I stated in the previous slide, that is the sign conventions, upward is positive. So RA upward plus sign, RB upward plus sign is equal to W, or we may say write down over here like this also. Sigma V is equal to 0. In that case, RA, which is upward, minus W, which is acting downward, plus RB, which is acting upward, is equal to 0. Therefore, RA plus RB is equal to W. These equations we have achieved. Next, sigma MA is equal to 0. I have to explain over here because this is our first problem. This is my supports, load W is acting over here. This is A joint. We did sigma MA is equal to 0. These two are the reactions, RA, RB. Now here we have to take a moment. Now we have to take a moment. What is the moment? Moment is nothing but the force into perpendicular distance. So RA into 0, it is 0. Now W, this distance is of L by 2. This creates clockwise moment. So W into L by 2 create a clockwise moment, and as per our sign convention, clockwise is positive. RB, this creates a moment anti-clockwise, so minus sign RB into perpendicular distance, that is L is equal to 0. And therefore, if you solve this problem, we found out RA is equal to W by 2 kilonewton. Please see over here. RB comes to be here in the slide, please. RB is equal to W by 2 kilonewton. Now, if we replace the value of RB in this equation, we can also obtain RA is equal to W by 2. So now I wish you will able to understood how to find out the reactions. Next, second problem. Second problem is just like a cantilever beam. One end is fixed, another is free, and at the free end the point load is applied over here. Now our aim is to find out HA, RA and MA. Applying the first equilibrium condition, sigma H is equal to 0. In the whole system, only single force HA is acting, so HA comes to be 0. Sigma V is equal to 0. Yes, upward RA is acting, downward W is acting, RA is equal to W because there is no any other force is acting, and sigma MA is equal to 0. So MA I have assumed as anti-clockwise. So if I will draw over here figure for your understood point of view, W MA, I have to take a moment over here. This is anti-clockwise, so I will write down minus MA. W create clockwise moment, so plus W into length is L, L is equal to 0, therefore MA is equal to W into L. So now in this problems we find out the three particular unknowns reactions with the help of the three equilibrium conditions, and hence this beam is also known as the statically determinate beam. Let us go to the next third problem. Overhanging beam subjected to the point load W at the tip over here. Now let us apply the first one, that is sigma H is equal to 0 condition. No horizontal force is acting over here in this system, only HA is acting, reaction comes to be 0. Second, sigma V is equal to 0. Two upward forces RA and RB, one downward, so RA plus RB is equal to W. Let us take the next one, that is sigma mb is equal to 0. Here sigma mb is equal to 0. And in that case, let us be solved over here so that understood better way. We are taking the moment over here at B. This is my RA, this is my RB. So RA into L is the first moment because of RA, which creates clockwise nature, so plus sign. RB into 0 because we are taking the moment over here. Next W. This creates moment in the clockwise, plus W into A is equal to 0. So what we achieve? RA is equal to minus WA by L. Minus sign, what does it mean? Minus sign shows that our upward direction of using RB is wrong. We have to use downward RB. Therefore, RA. Extremely sorry, we are discussing the RA. Upward sign is wrong, it is downward. Therefore, RA is equal to WA by L, downward. Now we have to putting the value of RA in the previous equation and we are able to find out RB. Please see over here. RB is equal to W minus WA by L, and we found out the value of RB. Next problem, number 4. A beam with UDL, simply supported beam is there, subjected to 10 kN per meter. UDL is acting along the length of beam 4 meter. See, this is the hinge connection, this is the roller connection. So I have to redraw the figure with the all forces, creates RAH and RAV, two reactions, and RB over here. Applying the first condition, sigma H is equal to 0, RAH is equal to 0, because only vertical loads are acting. Sigma V is equal to 0, RAV, that is acting upward, plus RB, which is acting upward, is equal to downward load. Let's take an example.